All right, problem 5 is a difficult problem. It says, given triangle ABC with these vertices, find the orthocenter. Okay, so let's just take a minute and plot all these points just so you can have a visual. Okay, so we have the triangle here, and it says find the orthocenter. You need to know what an orthocenter is, or you really have no chance on this problem. So orthocenter is the intersection, or the point of concurrency, of the altitudes. Okay, so if you can imagine, let's imagine from point A we have a altitude that comes down like this, right, perpendicular. And where is that altitude going to cross or intersect with another altitude? So maybe the altitude that's coming out of C would be a good one to use. So we want to know where these two altitudes cross. Okay, so it looks like we have an estimated answer somewhere in that region. Okay, so we could probably guess if this was a multiple choice test, 7,3 or 7,2, right? But here's how you do it the long way, the correct way. So let's back up for a minute, and let's find the slope of BC. The slope of this line will be a direct relationship with the slope of the green altitude. So let's find the slope of BC. Okay, slope of BC. M I'm using for a symbol for slope. So, you need the change in y. y2 minus y1, that's 1 minus 5, over 0 minus 8. Excuse me, I just made a mistake there. That's the slope of AB. I need to use points B and C. I need these points. So I need negative 2 minus 1. That's the y difference. And 9 minus 0. That's negative 3 over 9. That's negative 1/3. Okay, so negative 1/3, that means the slope of the green altitude should be the opposite reciprocal of the slope of this line. So the opposite reciprocal means to flip the fraction and make it positive if it's negative. So this slope will be 3. So we know that the slope, or the equation of the green line, looks like this. Okay, that's the slope. This is going to be the y-intercept. So all we need to do is find what the y-intercept is. Okay, so how are we going to find this missing letter? Well, we're going to use this point right here, the only point, point A, that's on the line. We're going to plug its values in for x and y. So 3, point A has 8 for x, 5 for y, plus b. It's 24, 5. Okay, subtract it. 24 to the other side. I can get negative 19. Okay, so that means our equation of the green line ultimately is this. Okay, that was a lot of work just to find the equation of one altitude. Now we need to repeat the process for a second altitude. All right, so I'm going to pause the video and just do all of the work the necessary, and then I'm just going to start it again to save some time. Which will do all the same things. So if you didn't hear any of that, rewind it and listen to what you need to do. We're going to do that again. Okay, so at this point we have our two equations. We have our equation for our green altitude right here, and the equation for our yellow altitude right here. The orthocenter will be where these two lines intersect. So I'm going to use substitution in order to solve the intersection of these two lines. Since they both are equal to y, we can set the other parts equal to each other. In other words, 3x minus 19 should equal negative 2x plus 16. All right? And if we solve this equation, we'll have the intersection of the two lines. Add 2x to both sides, 5x. Add 19 to the other side, we get 35. That, we get 7. So we have 7, comma, something. And all we need to do is take the 7, put it into one of the equations. So negative 2 times 7 is negative 14, plus 16 is 2. And this is the answer for where the location of the orthocenter is, which I told you at the very beginning, you could probably guess was about 7.2, 7.3, something like that. That's it.